This is a solar panel. This is at the heart of solar technology. It can be as small as this or as large as those massive panels you see on rooftops. It is a solar panel that collects energy from the sun and converts it to electricity that can be used to light up our homes and offices, as well as power our laptops and other electrical appliances. The solar panel is therefore the first building block of a solar system. The solar panel is also known as solar module or PV module, where PV stands for photovoltaic. The solar panel is a combination of multiple solar cells. Each solar cell is like a tiny power plant, and when we connect them together, we get a solar panel. These solar panels can be combined to create larger units called solar arrays. Obviously, the more the solar panels you have, the more the electricity you're able to generate. It is possible to light up our homes and power our electrical appliances direct with the electricity generated from the sun via the solar panels. However, if we do that on cloudy days or during the nights when there is little or no sunshine, there will be no electricity to use. To prevent that from happening, we need to find a way to store the electricity generated during sunny days to be used on cloudy days and during the nights when there is no sunlight. And that is where the batteries come in. The battery is the second building block of a solar system. A battery can be defined as an electrochemical device consisting of one or more electrochemical cells, which can be charged with an electric current. The battery stores the energy deposited in it during charging and gives out such stored energy also as electric current whenever it is required. In other words, batteries are a means of storing electric power to be used when it is required. There are different types of batteries ranging from rechargeable to non-rechargeable, lead acid to lithium ion, cylindrical to the rectangular, etc. In a subsequent video, I will go into details about different types of batteries and their characteristics. For now, suffice it to know that in a solar system, batteries are used to store energy from the sun to be used when the sun is down. Batteries are electrochemical in nature and are required to be recharged in an organized way. Unfortunately, the energy from the sun can be erratic and fluctuates according to the intensity of the sun. It therefore follows that to be able to charge the battery adequately, there needs to be a way to control or regulate the energy from the sun that goes to charge the battery. And that brings in the third building block of the solar system, the solar charge controller. The solar charge controller is used to keep the battery from overcharging by regulating the voltage and current coming from the solar panel to the battery. The solar charge controller regulates the electrical current to prevent the battery from electrical surges that can damage it and or reduce its lifespan. There are different types of solar charge controllers, ranging from the traditional pulse width modulation (PWM) technology to the more recent maximum power point tracking (MPPT) technology. Again, we will explore solar charge controllers in detail in a subsequent video. For now, let us just understand that solar charge controllers are needed to regulate the charging of the batteries to avoid damaging them or shortening their lifespan. Now, the type of electricity produced by the sun and fed to the batteries is the direct current DC electricity. For some reasons, the type of electricity we generally use in our homes is a different type of electricity called the alternating current AC electricity. It therefore becomes necessary to convert direct current to alternating current to be able to power our household appliances. And that brings in the fourth building block of the solar system, the power inverter. The power inverter, or simply inverter, is a power electronic device or circuitry that converts direct current DC electricity to alternating current AC electricity. From batteries, an inverter converts direct current DC into alternating current AC electricity that is used to power equipment designed to be powered by mains electricity. Again, there are different types of inverters, ranging from modified sine wave inverters to pure sine wave inverters. We shall explore inverters to a greater depth in our subsequent videos. In the meantime, let's make do with knowing that inverters are required to convert DC direct current DC to alternating current AC. Now, let's look at how we use this solar electricity. There are two main types of solar systems: the on-grid, also known as grid-tied, and the off-grid. An on-grid system is connected to the local electricity grid, what we used to call NEPA in Nigeria. If you have a large solar array, you may be able to generate more energy than you can use during the day on sunny days. In advanced countries, a solar system that is tied to the grid allows you to sell excess electricity back to the grid. In other words, the portion of the electricity that you generated from the solar panels that you are not able to use during the day can be sold back to the national grid. This is not happening in Nigeria at the moment, but we will get there someday. At the moment, the only option is to store your excess electricity in a battery to be used at night or on cloudy days. The second type is the off-grid. Here, the solar system is standalone, meaning it is not tied to the national grid. You generate your energy from the sun, store the energy in a battery, and from the battery, power your home via an inverter. The size and number of the solar panels you have will determine the amount of energy you are able to capture from the sun, while the size and number of batteries you have will determine how much of that energy you are able to store. Your inverter capacity will determine how much of that energy you are able to use. You will therefore need to be able to determine the size and number of solar panels required for your home. You will also need to determine the appropriate size and type of battery for your solar installation. For the panels to charge the battery bank adequately, you will need to determine the right size and technology of the solar charge controller. Now, no matter how much energy you have captured from the sun and stored on your battery, for you to be able to use the energy optimally, you will need to have the right size and type of inverter. That said, let's now look at why you should bother about solar technology at all. Why will anybody want to use solar technology? Truth is, there are many advantages of going solar. Let's explore some of them. The first advantage is that solar guarantees improved productivity. In our part of the world, power failure from the national grid is a near daily occurrence. Imagine you are preparing an important proposal for a client on your desktop computer and there is power failure. If you have a solar system installed, you are able to switch over to your solar system seamlessly. Being able to work when you want to is a major advantage of going solar. The second advantage is that solar is environmentally friendly. Solar is clean and green. Unlike fossil fuels, solar energy does not have carbon footprints or emissions, and as such, does not pollute the environment. The third advantage is that solar is abundant. Solar energy is the most abundant energy resource on Earth. About 173,000 terawatts of solar energy strikes the Earth continuously. That's more than 10,000 times the world's total energy use. Sunlight is not only the Earth's most abundant energy source, it is also delivered free of charge to us. All we need to do is find a way to harness it. The fourth advantage is that solar requires very low maintenance. Once installed, solar panels typically require very low maintenance. Oftentimes, all that is required is for the surface of the panels to be clean, free of dust and particles. This is largely because there are no moving parts in the system. The only maintenance cost that is certain is the inverter, which is typically replaced after the system has been operating for roughly 15 years. The industry standard for most solar panels lifespan is 25 to 30 years. Many reputable manufacturers offer production warranties of 25 years or more. The fifth advantage is that solar confers long-term cost savings. While it may be expensive to install solar at the beginning, over time, it will usually lead to substantial cost savings. The average break-even point for solar panel energy savings occurs 6 to 10 years after installation, depending on the configuration of your solar system. Well, that's it. Solar 101, Solar Energy Explained. If you found this video helpful or interesting, give it a thumbs up, share it with your friends, click the subscribe button and turn on the notifications bell for more valuable content on what you should know about solar technology. Thank you for joining me today. As always, stay curious, stay green, and I'll see you in the next video. Bye for now.